the right side of this graph doing?
Down.
Going down.
Oh, right. Yeah.
So your answer would be
Negative.
-infinity.
Oh, that's how we're gonna do this?
Yes.
We can't plug infinity in.
Well, you
so
can
So
actually.
it's a positive increment. Wait, now I have to do the math. Oh wait, do we have to fill that out? Or is there just like an imaginary positive one at the beginning?
Give me a minute.
I definitely remember doing that dance in this murder.
I do too.
Yeah. We would all go. You'd be like, the funniest part about this test is watching you all like this. Yeah, doing some Egyptian dance over here trying to figure out where you guys were.
That's awesome.
Chandler was pretty funny.
Alright. So the next one.
She said,
Whew. So the next one, basically you just have to worry about the leading coefficient and the degree, which is the highest.
So it's 1.
So let's look at
Link coefficient would be
these.
4. No. I'm confused. I don't know why I did that.
It would be the one with the highest exponent.
Yeah.
So x squared.
So I have, negative x times negative x times x times x.
So x to the 4.
Question again.
Yes.
Okay, you split up the negative x squared.
Yes, that's because it was squared. Yep. So, again,
Well, you could have just left it together.
yeah, and squared it. That would have been okay.
Wouldn't that have been quicker?
Probably, but I might have lost some people.
You lost it.
So the degree is even.
So it goes.
So same direction, yep. And the leading coefficient is
So
positive.
they're both going up. I don't know. Who said up?
Yeah.
Okay, I'm pretty sure that's how positive and negative works. Positive goes up,
Yep.
negative goes down.
So as I approach the left,
Touchdown.
as I approach the left,
You better make it like this.
it's going up.
Make it curved. Yeah, we're gonna be back here doing this. Am I curved? I don't know. It can be a small curve. I don't know.
Left is the.
Judging its curve.
Okay, so this next one is a rational function.
You didn't write your age.
Yeah, it is, right here.
Oh, it's just tiny.
The rational functions, we worry about horizontal asymptotes.
Bottom head and your top head.
Exactly.
It's even.
Or slant. So we look at the negative 2x over the x. So is that, for the x's, bottom heavy, same heavy, or top heavy?
Same.
Same. Same heavy because they have the exact same exponent on top and on bottom. I need to write that somewhere else, sorry. So then what is our horizontal asymptote?
0.
It's, that's if it's bottom heavy.
Negative
It's leading coefficient. If it's same heavy, it's leading coefficient over leading coefficient.
negative 3.
Negative 2, it's the number in front of the x. That's the leading coefficient, even though it's not in the lead. Weird, huh? Over 1, because there's a 1 there. So it's negative 2. So as I approach from the right or the left, it would equal the horizontal asymptote.
I was like, there's like 3 answers. You don't like this. No, we're kind of going. Well, but
Yes.
the horizontal asymptote.
Are you surfing this game?
What?
Are you surfing?
I am. I'm surfing calculus.
Yeah.
No.
Oh, yes.
Wait, just surfing.
I'm hanging
Never
limits.
touch it. I don't want to touch it.
Oh, that was.
I was going to say, if we're surfing, we're like not touching it.
That was a little ha-ha.
Yeah, a little pop.
Aloha.
A small chuckle.
That's a lot for me. You know it is. Okay, so that third example, that last one we did, helps us figure out what we're going to do when we have rational functions, which we really just talked about. So on this one for f of x, we would call that what kind of heavy?
Same. Oh, bottom. Yeah, so you want
Yeah, there's only a variable on the bottom, so it is bottom heavy.
So it's at 0.
If it's bottom heavy, then the horizontal asymptote is at 0.
So the answer is 0.
What about g of x?
G of x.
It's bottom.
Bottom.
That's also bottom heavy.
So it's still
So again, you can see that the asymptote is at 0. So what this means, algebraically,
Big word.
mhm,
There's an I in that. No word.
the numerator is a constant, and the denominator
Oh, well, we're writing. I'm just like.
is some power of x. That's what makes it bottom heavy. Or, then they have horizontal asymptote at y equals 0.
Somebody got sticky shoes. I'm just sleeping out.
half chocolate.
You're actually wearing chocolates? With socks. Yeah.
I've worn it every day this school year.
I'm sorry I don't look at your feet.
I don't think I've worn tennis shoes yet.
I wore sandals twice.
No, I did like.
I'm kind of worried to wear chocolates at school. Like, I don't know, that seems weird. I don't like my tennis.
Wow.
I don't know. It seems like a summer shoe, and like school doesn't really make me think summer.
I still probably wear it.
I think toes are inappropriate for school, just like shoulders should be.
What?
If shoulders are inappropriate, then so are toes.
That makes no sense.
Neither does not be able to wear a tank top, but it's fine.
Yeah.
You wear a tank top.
As long as it's an inch.
There should be no dress code.
Facts.
Oh, trust me. You
I
are
think-
thankful there's a dress code.
Oh, I am, but I think
I can't wear
dress code
shorts.
should loosen up a little bit.
I want to be able to wear shorts.
Yeah, because
It's hot.
we're 90 degrees outside.
Take an inch, take a mile. Tell you can wear it here, people start wearing them up here. It's crazy.
I mean,
Tis the truth.
Brooklyn doesn't have
Look
a dress
at people
code.
of Walmart.
No,
That's all I'm
Brooklyn
saying.
does have a dress
No
code,
dress
but they
code
can
for
wear
there.
shorts.
Brooklyn allows shorts and no one pushes it. Everyone's just excited.
Well, that's Brooklyn.
No, the thing is that their shorts have.
Okay, so for the next page.
If they don't, they get in trouble. It's like their shorts. Yes.
We know, we already have a picture over here. We can figure this out without doing it the calculus way. But I am going to show you the calculus way because this is why the stuff works. This is why bottom heavy is always y equals 0.
Yeah, but we-
This is why same heavy is always leading coefficient over leading coefficient. This is one of those things last year that I told you in calculus we'll figure out why. Now we're about to figure out why. Okay, so just looking at this one,
Bottom heavy.
Bottom.
it's bottom heavy, so that means there's a horizontal asymptote where?
0.
0. So if I approach infinity, what's the limit? 0. And that's the way I want you to do this problem.
Do we have to explain?
But if you do, well, bottom head, nah. But I am going to show you how this came about, and it is important. All right.
It's important.
No, what we're going to do is, where does it say? Here we go.
We can
We're going to divide every term in the numerator and the denominator by this highest power of x
Oh my gosh.
that appears in the denominator. So what I mean by that is we're going to divide everything by x squared because the variable with the highest power in the denominator is x squared.
Do you have to divide x squared by x squared?
But that's just
Yep.
gonna cancel out, so that's not gonna be
And as long as we're dividing everything by the same thing, we're not changing anything.
Oh,
We're just changing the way it looks.
I did that way wrong. Oh wait, but it's added. Can we get rid of that X?
Well, we're going to simplify. So that's 1 over x on top, right?
Yes.
Yeah.
Plus 2 over x squared. Over 1, yes. Plus 5 over x. Plus 6 over x squared. Now to figure out a limit, what do you do? If it was just limit as x approaches, yes, you said it. Plug it in. So if I plug in infinity, I get
With infinity.
1 divided by infinity.
You know, could you just
Plus 2 divided by infinity squared.
A squared.
Well,
You know, you could just plug in infinity, yeah?
Infinity. Plus 6 over infinity squared. Okay, so let's think about that. If you have a number and you divide it by an infinitely large number,
Pi. It's infinity.
think about it. If I have 1 and I'm dividing it by a gazillion,
It's infinity.
No.
1.
A gazillion.
take 1, divide it by 10. You get 0.1. If you take 1 and you divide it by 100, you get
-0.01.
0.01.
1 to the negative
1 divided by 1,000.
infinity power.
So it's
0.001. What is it getting closer and closer to?
0.
0, which you guys did finally say, but you were just throwing out numbers. So yes, I'm going to put that over here.
So 0.
So anything divided by infinity is 0. So I have 0 plus 0 over 1 plus 0 plus 0.
Which is 1 over 0 over 1.
Which is 0.
Which is 0. Cool deal.
So that's why it's 0, if it's bottom heavy.
Homecoming elections start at 10 a.m. and close tomorrow at 10 a.m.
That's
Everyone
crazy.
And we will stop there
Yeah.
and finish this up tomorrow.
And then I got it now.
You go for 3